Let's now discuss absolute value questions that include the greater than or equal to signs. If an inequality includes a greater than or equal to sign, then the result is two separate intervals moving away from 0. So in this case, the absolute value of x is greater than 5. So on this side of negative 5 is where you would find negative 6, negative 7, negative 8, negative 100. And the absolute value of all of those numbers are greater than 5. So this interval on the left side is moving towards negative infinity. Or we have the absolute value of x is greater than 5. So if x is positive, you go to positive 5. And then on the right side of 5 on the number line is where you have greater than 5. So on this side is where you have 6, 10, 100, 1000, and so on. So we see when we had less than, the two lines were moving toward each other to meet at 0. For greater than, the two intervals are moving away from each other since the absolute values are greater than some number. So on the positive side, they're going to become more positive. And on the negative side, they'll become more negative, pushing them away from each other this time, not towards each other. It's the same when we have greater than or equal to. The only thing that changes is the numbers in the interval are now included, but the values are still moving in the same direction. So let's walk through an example together. Solve for x and check the answers. The absolute value of x plus 3 is greater than 4. So for this one, create the first inequality by removing the absolute value sign. So we have x plus 3 is greater than 4. And now we can solve for x. So we'll subtract 3 from both sides, showing us that x is greater than 4 minus 3, which is positive 1. So this is the interval that is positive. So it's on the right side of 0 on the number line. So step 3, what we want to do is reverse the inequality from step 1. So we want to change the greater than sign to less than. And step 4, we want to make the value of the inequality negative. So we change positive 4 to negative 4. And now x plus 3 is less than negative 4 is the inequality that represents the interval on the left side of 0 on the number line. So now again, we can solve for x. So we'll subtract 3 from both sides. And we have x is less than negative 4 minus 3, which is negative 7. So we have our two intervals. X is greater than 1 and x is less than negative 7. So we can check the answers by plugging 4 numbers into the original inequality. So we'll plug in 2 numbers to test this interval. And then we'll plug in 2 numbers to test this interval. So starting with the negative interval, we have x is less than negative 7. So we'll plug in negative 8, which is less than negative 7, so that should work. And then we'll plug in negative 7 for x, and that should not work. So we plug in negative 8 for x, we get negative 8 plus 3, which is negative 5. And the absolute value of negative 5 is 5, giving us the true statement 5 is greater than 4. So negative 8 worked as we were expecting. Now let's plug in negative 7. Negative 7 plus 3 is negative 4. The absolute value of negative 4 is 4, giving us the false statement 4 is greater than 4. So we see by plugging in negative 8 and negative 7, we see this interval is true. And now to test the positive interval, x is greater than 1. We want to plug in 1 for x, since that should not work. 1 is not greater than 1. And then we'll plug in 2 for x, since that should work. So when we plug in 1 for x, we get 1 plus 3, which is 4. The absolute value of 4 is 4, giving us the false statement 4 is greater than 4. And now we plug in 2 for x, giving us 2 plus 3, which is 5. The absolute value of 5 is 5, giving us the true statement 5 is greater than 4. So those two numbers prove that this interval is correct. So we see the answer to this question is x is greater than 1 or x is less than -7. And that is how you go about solving greater than absolute value questions. Let's now have you complete a few practice questions. Solve for x and check the answers. Question number 1. The absolute value of -2x plus 7 is greater than 11. Question number 2. The absolute value of 4x minus 1 is greater than or equal to +7. Question number 3. The absolute value of 3x minus 6 is greater than 15. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We are given the absolute value of -2x plus 7 is greater than 11. Step 1, create the first inequality by removing the absolute value sign. So we have -2x plus 7 is greater than 11. So we'll start by subtracting 7 from both sides, giving us -2x is greater than 11 minus 7, which is 4. And now to remove this coefficient of -2, we want to divide both sides by -2, giving us x. We're dividing by a negative number, so we want to reverse greater than to less than. And 4 divided by -2 is -2. So that gives us x is less than -2 as our first interval. And now we want to find the second interval. So step 3, we want to reverse the inequality sign from step 1, which is greater than here, and change it to less than. And step 4, make the value of the inequality negative. So instead of +11, we have -11. And now we can solve this inequality for x. -2x plus 7 is less than -11. So we'll start by subtracting 7 from both sides, giving us -2x is less than. -11 minus 7 is -18. And now we want to divide both sides by -2, giving us x. We reverse less than to greater than. -18 divided by -2 is +9. So the second interval that we get for our solution is x is greater than 9. So now that we have the two intervals that represent our solution, we want to check the answers by plugging 4 numbers into the original inequality. When we do so, we'll first plug in 2 numbers to test this interval. We have x is less than -2. So we'll plug in -3 to make sure that works, and then we'll plug in -2 to make sure that does not work. When we plug in -3 for x, we get -2 times -3, which is 6. 6 plus 7 is 13, and the absolute value of 13 is 13, giving us the true statement, 13 is greater than 11. And now we plug in -2 for x, giving us -2 times -2, which is 4. 4 plus 7 is 11. And the absolute value of 11 is 11, giving us the false statement, 11 is greater than 11. So by plugging in -3 and -2, we see that this interval is correct. And now we want to test x is greater than 9. So we'll plug in 9 to make sure that does not work. And then we'll plug in 10 to make sure that does work. When we plug in 9 for x, we get -2 times 9, which is -18. -18 plus 7 is -11. And the absolute value of -11 is +11, giving us the false statement, 11 is greater than 11. And now we plug in +10 for x. -2 times 10 is -20. -20 plus 7 is -13. And the absolute value of -13 is 13, giving us the true statement, 13 is greater than 11. So by plugging in 9 and 10, we see that this interval is true. So both intervals work. letting us know that the answer to question number 1 is x is less than -2 and x is greater than 9. Let's now have a look at question number 2. We were given the absolute value of 4x minus 1 is greater than or equal to positive 7. So step 1, create the first inequality by removing the absolute value sign, giving us 4x minus 1 is greater than or equal to 7. And now we can solve for x. So we'll add 1 to both sides, giving us 4x is greater than or equal to 7 plus 1, which is 8. And now to remove this 4, we divide both sides by 4, giving us x is greater than or equal to 8 divided by 4, which is 2. So the first interval for our answer is x is greater than or equal to positive 2. So now we want to put that to the side and find the second interval for our answer. So step 3, we want to reverse the inequality from step 1. So we change greater than or equal to less than or equal to. And then step 4, we make the value of the inequality negative. So instead of positive 7, we have negative 7. And now we can solve for x. So we'll add 1 to both sides, giving us 4x is less than or equal to negative 7 plus 1 is negative 6. And now we want to divide both sides by 4 to get rid of this coefficient of 4, giving us x is less than or equal to negative 6 divided by 4 is negative 1.5. So the two answers are x is greater than or equal to 2, or x is less than or equal to negative 1.5. And we could check the answers by plugging 4 numbers into the original inequality. The absolute value of 4x minus 1 is greater than or equal to 7. So starting with the negative interval, we'll plug in negative 1.5 to make sure that works. And then we'll plug in negative 1 to make sure that does not work. When we plug in negative 1.5 for x, we get 4 times negative 1.5, which is negative 6. Negative 6 minus 1 is negative 7. And the absolute value of negative 7 is 7, giving us 7 is greater than or equal to 7, which is a true statement. So negative 1.5 works. We then plug in negative 1, since that should not work. 4 times negative 1 is negative 4. Negative 4 minus 1 is negative 5. And the absolute value of negative 5 is 5, giving us the false statement, 5 is greater than or equal to 7. So by plugging in negative 1.5 and negative 1, we see that this interval is true. And now we want to test x is greater than or equal to 2. So we'll plug in 1 to make sure that does not work. And then we'll plug in 2 to make sure that does work. When we plug in 1 for x, we get 4 times 1, which is 4. 4 minus 1 is 3. And the absolute value of 3 is 3, giving us the false statement, 3 is greater than or equal to 7. And now we plug in 2, giving us 4 times 2, which is 8. 8 minus 1 is 7. And the absolute value of 7 is 7, giving us the true statement, 7 is greater than or equal to 7. So by plugging in 1 and 2, we see this interval is correct, showing us that the answer to question number 2 is x is less than or equal to negative 1.5, or x is greater than or equal to 2. Now let's review question number 3. We were given the absolute value of 3x minus 6 is greater than 15. Step 1, create the first inequality by removing the absolute value sign. That gives us 3x minus 6 is greater than 15. And now we can solve for x. We'll begin by adding 6 to both sides, showing us 3x is greater than 15 plus 6 is 21. And now to remove this coefficient of 3, we divide both sides by 3, giving us x is greater than 21 divided by 3 is 7. So the first interval of our answer is x is greater than 7. And now to find the second interval of our answer, step 3, we want to reverse the inequality from step 1. So from greater than to less than. In step 4, we want to make the value of the inequality negative. So instead of positive 15, we have negative 15. And now we can solve for x. So we have 3x minus 6 is less than negative 15. So we want to add 6 to both sides, giving us 3x is less than negative 15 plus 6 is negative 9. And now we want to divide both sides by 3, showing us x is less than negative 9 divided by 3 is negative 3. So the second interval of our answer is x is less than negative 3. In step 6, we can check the answers by plugging 4 numbers into the original inequality. The absolute value of 3x minus 6 is greater than 15. So to test this interval, x is less than negative 3. We'll plug in negative 4 to make sure that works. And then we'll plug in negative 3 to make sure that does not work. 3 times negative 4 is negative 12. Negative 12 minus 6 is negative 18. And the absolute value of negative 18 is 18, giving us the true statement 18 is greater than 15. And when we plug in negative 3 for x, we get 3 times negative 3, which is negative 9. Negative 9 minus 6 is negative 15. And the absolute value of negative 15 is 15, giving us the false statement 15 is greater than 15. So by plugging in negative 4 and negative 3, we see that this interval is correct. And now we want to test x is greater than 7. So we'll plug in 7 to make sure that does not work. And then we'll plug in 8 to make sure that does work. 3 times 7 is 21. 21 minus 6 is 15. And the absolute value of 15 is 15, giving us the false statement 15 is greater than 15. And when we plug in 8 for x, we get 3 times 8, which is 24. 24 minus 6 is 18. And the absolute value of 18 is 18, giving us the true statement 18 is greater than 15. So by plugging in 7 and 8, we see that this interval is correct. So the answer to question number 3 is x is less than negative 3, or x is greater than 7.